In Activity 9, Tides, students learn how the gravitational pull of the moon moves ocean water. Students first review the spatial relationship between Earth and the moon, and then model the effect of the moon's gravitational pull on Earth and its oceans. Finally, students infer that there are 2 high tides and 2 low tides along most coastal regions each day. You will need the following materials from the kit: Activity Sheet 9, paper fasteners, rubber bands, manila folders, Tidal Dial resource sheet, and the Tidal Dial transparency. You will also need to provide scissors, crayons, glue, and a projector. To prepare for the activity, make 1 copy of Activity Sheet 9 and the Tidal Dial resource sheet for each student. You will also need the Tidal Dial transparency, a projector, a pair of scissors, and 1 rubber band. Then cut the manila folders in half along the crease. Each student will get half a folder, a paper fastener, a rubber band, and a pair of scissors. Students will share the crayons and the glue. To begin the activity, encourage students to recall if they have ever spent a day at an ocean beach. Ask students what happened to the water line over time. Students may have noticed that the water line moved, either advancing or receding over the course of several hours. Explain to the class that tides are very large bulges of water that cause the surface level of the oceans to rise and fall at regular intervals. Then ask, what do you think causes the tides? Some students may know that the moon has something to do with tides. Accept all answers. Next, distribute the materials to the class and point out the Earth and Moon discs on the resource sheet. Instruct students to color the Earth disk blue and the Moon disk brown, and then cut out both discs. Then, poke a small hole in the center of the Earth disk. Cut out the dial from the resource sheet and glue it to the folder. Trim the folder to size and poke a hole in the center of the dial large enough for the pencil to pass through. Finally, push a paper fastener through the slit in the center of the Earth disk and attach it to the center of the dial. Place the moon piece anywhere along the outer edge of the dial. Draw attention to the Earth disk in the center of the dial. Explain that this disk represents Earth as seen from above the North Pole. Ask students, how does Earth move? Help students understand that the Earth rotates on its axis counterclockwise from west to east. Turn the Earth disk counterclockwise to simulate Earth's rotation on its axis, and then review that it takes Earth 1 day, or about 24 hours, to make 1 complete rotation on its axis. Bring students' attention to the smaller dial inside the large dial, and explain that this dial is a kind of clock because it represents the number of hours in a day. Then instruct students to note the time and to turn the Earth disk until the X lines up with the proper hour on the small dial. Next, bring students' attention to the moon disk. Ask students, how long does it take for the moon to make 1 complete revolution around Earth? Help students understand that it takes about 29 days for the moon to completely revolve around the Earth. Inform the class that the large outer dial represents the path of the moon as it revolves around Earth. Next, instruct students to place the moon disk on the current day and then to move Earth and the moon simultaneously, with the moon advancing 1 day, or 24 hours, for each complete rotation of the Earth. Place the rubber band around the Earth disk so that the disk is centered inside the band. Inform the class that the space between the edge of the Earth disk and the rubber band represents the oceans that cover nearly 3/4 of Earth's surface. Hold up a pencil and then drop it for all students to see. Ask students, what made this pencil fall? Most students will know that gravity pulled the pencil downward, making it fall toward Earth. Help students understand that gravity is an attractive force that exists between all objects, and that the larger and closer an object is to the ground, the greater the gravitational pull it exerts. For instance, just as Earth exerts a gravitational pull on us and all the objects around us, the Moon exerts a strong pull on Earth. Have students look at their tidal dial again and ask, on which side of Earth do you think the Moon's gravitational pull is greatest? Students should respond that the gravitational pull is greatest on the side facing the Moon. Instruct students to stretch the rubber band so that it bulges on the side of Earth facing the Moon. Inform them that the side of Earth facing the Moon experiences high tide due to the Moon's gravitational pull on Earth's oceans. Next, slide the Earth disk very slightly toward the Moon to create two bulges of the rubber band on opposite sides of the Earth disk. Explain that the Moon also pulls on the solid part of Earth very slightly. Then have students slide their Earth disk toward the Moon. Further explain that the bulge of water on the side of Earth opposite the Moon is caused by forces related to Earth's motion. Ask students, how many high tides are there at any given time on Earth? Students should be able to see that there are two high tides on Earth at any given time, one on the side facing the Moon and one on the opposite side of Earth. Ask students, when does low tide occur? Students should figure out that low tide occurs between high tides. Ask what causes low tide. Help students understand that low tide is caused when water drains from the region between two tidal bulges. Low tide is the trough between two enormous wave crests. Then, on the tidal dial transparency, place the Moon at day 1. Line up the Earth disk so that the X is at 12 midnight, and position the rubber band to simulate high tide at that time and location. Move the Earth disk a quarter turn without disturbing the rubber band. Ask students, is it now high tide or low tide where you are? Students should identify the tide as low. Ask how many hours are represented by a quarter turn of the Earth disk. Students should calculate that a quarter turn of the Earth disk represents about 6 hours. Then ask, how many hours are there between high and low tide? Again, students should deduce that there are about 6 hours between high and low tide. Next, have students turn the Earth disk another quarter turn to high tide again. Ask students how many hours have passed since the last high tide. Students should respond that this time about 12 hours have passed, and that the next low tide will occur in about 6 hours. Finally, high tide will occur about 6 hours after that, or in about 12 hours. Point out to students that they did not move the rubber band while turning the Earth disk, and that the high tide bulge remained oriented toward the Moon. Ask students, what can you conclude from this? Guide students to understand that Earth's rotation causes high tide, not the movement of the water itself. After one complete rotation of the Earth, have students advance the Moon one space to day 2 and readjust the rubber band so that the bulges are again aligned with the Moon. Ask students, do high and low tide occur at the same time every day? Students should understand that the Moon is moving very slowly around Earth as Earth rotates, and that high and low tide occur a little less than an hour later each day. After students have finished their work with the tidal dial, distribute Activity Sheet 9 and have them complete it. Finally, inform students that in the next 3 activities, they are going to turn their attention to some of the life forms that dwell in Earth's oceans. To conclude this activity, let students keep their tidal dials. Note that you will need 5 assembled tidal dials with rubber bands for the assessment activity. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.